All right, we are looking at several theorems in conjunction with arcs and central angles and another thing called a chord. Well, you know that a diameter goes from one side of a circle through the center to the other side, but what if it doesn't go through the center? We simply call it a chord. So that's what a chord is, a segment whose endpoints are on a circle. So a diameter is a kind of chord. It's the longest chord of a circle. The farther away from the center, the shorter the chord. So we've got a couple of theorems. Within a circle or incongruent circles, congruent central angles have congruent arcs. So if this central angle is the same as this one, the arcs would be the same measure. And then the converse holds true. If within the circle or in the congruent circles, congruent arcs have congruent central angles. Makes perfect sense. The next one, within a circle or in congruent circles, congruent central angles have congruent chords. So the difference is that the angles, the arc measures are the same here and here, but also if we drew a line segment, those segments would be congruent. And the last one here, or that's actually not the last one, but the last one on this page, says that within a circle or in congruent circles, congruent chords have congruent arcs. So if these chords are the same measure, then the corresponding arc that is created by them are also the same measure. Okay? And the converse of that holds true as well. All right, let's move on. Make sure you are copying these down or you're downloading these notes so that you can refer to them during assessments. Within a circle or incongruent circles, chords equidistant from the center or centers are also congruent. So this chord is the same distance from the center as this chord. It says so right here in the red marks. That means AB and CD would be congruent, and the converse will hold true as well. We're using these in some of our examples, these theorems. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and it bisects the arc, just as long as it's perpendicular. In a circle, if a diameter bisects a chord, then it is perpendicular to the chord. So that's the converse of what we just said. So if it's bisects the chord, then we know that it is perpendicular to the chord. And the last one I'm going to show you, in a circle, the perpendicular bisector of a chord will contain the center. Notice I don't have the center marked here. This is the perpendicular bisector of that chord. Well, this would have to contain the center of the circle right there. So again, make sure you get these in your notes, whether you download the pages or whether you copy these down so you have them, because there's quite a few of these theorems, and that we'll use them when we look at these examples.